All right, so I'm going to go over free response question 5 from the 2023 AP Statistics exam. The official solutions will be out in probably June or July. And so these are just going to be my solutions. And so if you have any questions or if you notice maybe something seems like I made maybe made a mistake, just let me know in the comments. All right, problem 5. Wildlife biologists are interested in the health of tule elk, a species of deer that's found in California. An important measurement of the tule elk health is their weight. The weight of a tule elk is difficult to measure in the wild. However, chest circumference, which is believed to be related to the weight of a tule elk, can easily be measured from a safe distance using a harmless laser. A study was done to investigate whether chest circumference in centimeters could be used to accurately estimate the weight in kilograms of male tule elk. So for the study, the wildlife biologist captured 30 male tule elk, measured their chest circumference and weight, and then released the elk. The data for the 30 male tule elk are shown in the scatter plot. Okay, so you can see that the chest circumference is across the x-axis, so that's going to be our explanatory variable, and the weight is the vertical axis, so that's going to be the response variable. And part A is telling you to describe the relationship between chest circumference and the weight of male tule elk in context. Okay, so when you're told simply to describe the relationship, or maybe they say describe the association between two quantitative variables, there are 4 key things you need to address. Remember the word or acronym DOFs. You want to address the direction, if there are any outliers, the form, and the strength. So the direction appears to be positive. It seems to be like a strong relationship, or we can say maybe moderately strong. It seems to be linear. And when you're talking about shape, just say linear or nonlinear. Don't get all complicated with like saying like parabolic or exponential, because in this course you're not going to go that deep into those types of relationships. So just keep it simple, linear or nonlinear. And then we say between X and Y, or in this case, between chest circumference and the weight of the male tule elk. And there doesn't appear to be any outliers. So those 4 key characteristics is what I'm going to assume they want for full credit on this part. All right, part B. Here's the least squares regression line relating chest circumference and the weight for the male tule elk. We're given predicted weight is equal to negative 350.3 plus 3.7455 times chest circumference. And we're told the weight of one male tule elk with a chest circumference of 145.9 centimeters is 204.3 kilograms. Part 1, we're going to use the equation of the least squares regression line to calculate the predicted weight for this male tule elk. Okay, so remember, the predicted weight, that's going to be our y hat. And the chest circumference is going to be our x, our explanatory variable. So remember, this is the form typically is y hat equals a plus bx. So you simply just have to recognize that the chest circumference is the x variable, or the value of, the explanatory variable, and that this will I'm going to talk about in the next part. And then we just plug that into the equation here. Plug 145.9 into here, and we're going to get 196.16845 kilograms. Okay, residual. Calculate the residual for this male tule elk. Okay, now this is an estimation or a prediction. This is the predicted weight. So the residual is the actual weight minus the predicted weight. So the actual value minus the predicted value. And we're told that the actual value is right here, the 204.3. This is the actual value of the weight for this male tule elk with the chest circumference of 145.9 centimeters. So the residual will be equal to this value minus this, actual minus predicted, which will be about 8.13155 kilograms. So a good way to remember residual, maybe remember the wrap. Residual equals actual minus predicted. All right, part C. Here's the equation of the least squares regression line again. Interpret the slope of the least squares regression line in context. Okay, so remember slope, just as you learned in like your algebra 1 days. Slope is on an XY plane is the change in Y over the change in X. So in context, think about what the X variable represents and what the Y variable represents. And we're going by a unit. So we want to basically look at, for each change in X, what is the Y value changing by? So then this is our slope. The slope is this value right here. Our delta X is a 1. Our delta Y is a 3.7455. And then from there, we know that the chest circumference is the X and the weight is the Y. So each time our chest circumference goes up by 1 centimeter, the predicted weight will increase by 3.7455 kilograms. So that's one way of wording it. So remember, slope change in Y or change in the response variable for each unit change in the explanatory variable. All right, and part D. Cover that up a little bit. The sambar, another species of deer, is similar to the size of the tool elk. The slope of the population regression line relating chest circumference and weight for all male sambars is 4.5 kilograms per centimeter. A wildlife biologist wants to determine whether the slope of the population regression line for male tool elk is different than that for male sambars. Let beta represent the slope of the population regression line for the male tool elk. The wildlife biologist conducted a test of the following hypotheses using a sample of 30 tool elk. And what we have here is a null hypothesis for beta is 4.5, and the alternative is that beta is not 4.5. The test statistic was calculated to be 3.408. And we're going to assume all the conditions for inference were met, and we want to determine the p-value of the test. So all we're simply going to run here is a t-test where we're going to determine what's the probability of getting, a statistic 4.5 or greater in either direction, or less than negative 4.5. Well, actually, no, sorry, I misworded that. What's the probability of getting a test statistic this extreme or more extreme in both directions? So this is associated with that. I guess they already ran the calculation for us in the way where we don't need to know like the standard deviation and all that stuff. So I basically just, I'll go through to my calculator in just a second, but it's a two-sided t-test. Two-sided when you first learn, how to calculate significance tests for difference in means, you would either look at one side if it's greater than, or the other side if it's less than. If it's not equal to, you look at both sides. So we have a t-distribution looking for the areas to the right of 3.4-ish and to the left is negative 3.4-ish. And we use the degrees of freedom of 28 in our calculator. So this can be simply done if you go to stat test in your calculator, just go to t-test. And actually, no, you don't have to do that because you're already given them. Go to distribution, that's what I meant to be. Distribution and go to TCDF. Now this calculator is old school, so we just write the lower bound first, 3.408, comma, followed by an upper bound, just put like a very large number, comma, followed by the degrees of freedom. The degrees of freedom is the sample size minus 2. And this will give you that area there to the right. But since it's a two-sided test, I'm going to multiply this by 2, and that'll be my p-value. The p-value will be about 0.002. And the last part, so based on a significance level of 0.05, what conclusion would you make regarding the slope of the population regression line from male to elk? So since we have a p-value that's less than our 0.05 alpha level, we're gonna reject the null hypothesis. In other words, we're gonna reject believing that the true population slope is 4.5. We're gonna say we were gonna reject this because we have convincing or statistically significant evidence to claim and or state that the true slope is not equal to this value. So in whatever word you want to, in whatever way you want to word it, but you basically want to connect your p-value with the rejection of this, and or the p-value with want to connect this p-value leading to rejecting the null hypothesis because it's less than our alpha level. Okay, so there you go. I hope that helps. So let me know if you have any questions.